I'm Evaline. I work as a software engineer in the IBM research group. And today I'll be talking about orchestrating guardrails in generative AI workflows. And so this might be useful if you want to add guardrails to your LLM applications, or some of the considerations I'll talk about here might be useful if you're building on your own LLM applications as well. So quick overview of the agenda. I'll talk about our definition of guardrails, the challenges of adding guardrails to LLM and inference workflows, a bit about our ecosystem of guardrails, which includes a couple different components, including chunkers, detectors, generation model servers. We'll go over the details in a bit, and of course, the guardrails orchestration. So to begin, we talk a little bit about the challenges of generative AI. So a lot of these people might be really familiar with. Hallucination, the model may assert something, perhaps really confidently, but be very wrong. Fairness, the model may present or reflect biases in its answers or decisions. And prompt injection, like users can get very creative in prompts to models or systems, and then the model might say something really unsuitable, like leaking information, or potentially saying something really profane. So to deal with that, we have guardrails. So here we say guardrails are solutions aimed to improve the safety and reliability of LLM-based applications, ideally with minimal overhead. And today we focus on detectors as guardrails. So there's a lot of different examples, including those that can detect some of the challenges we talked about, like hallucinations or prompt injections. But there's also other examples, like detecting hate, abuse, and profanity, so HAP. Or ones that might have different sorts of inputs, including answer relevance, where you might want to compare the model generation output to the original user prompt to see if that was relevant. There's also different detector formats, including LLMs themselves, like risk LLMs, such as IBM's Granite Guardian or Meta's Llama Guard. So these will basically say things like Granite Guardian will say, oh, yes or no on risk, with regard to a particular risk, and then say if there's high or low confidence for that decision. And Llama Guard will basically say if something is safe or unsafe, and if it's unsafe, it'll give you a categorization of why it thinks it's unsafe. And so before we talk about adding guardrails to the LLM inference workflow, we just want to go over what area of the model lifecycle I'm talking about. So to start, the user just gives a user prompt, and the LLM returns a generation. When we add guardrails, we add a little bit more to the inference workflow. So when the user gives a user prompt, there can be one or more detectors configured that can be used to screen the user prompt, and then the detections can be returned to the user. If there's nothing deemed sort of unsuitable, this can continue in the workflow. The prompt is given to the large language model and the generation returned. And then with the generation, we can run the same or potentially a different set of detectors on the generation and return that along with any detections to the user. And so seems fairly simple, but obviously, as we all know, in building LLM applications, potentially many challenges can crop up. So some of the challenges we face designing this include there's a lot of different LLM serving solutions out there. There's a lot of detection types, a lot of sorts of detectors that people might want to add to their workflow. And of course, this comes along with a lot of different APIs that people will serve or provide detectors with. Another consideration we had was how do we deal with unary versus streaming output? People don't like to wait minutes for their models to generate like a story. So maybe they'll want to see the output coming out in real time, so tokens might return a few at a time, and so we still want to be able to run detections on those. And other challenges we faced was adding or considering performance for the system. So we want to ideally have minimal overhead when we're adding guardrails. And then lastly, we want to be able to configure flexibly. Like there's a lot of different generation models, a lot of detectors out there. How do we let people easily add them to the inference workflow? So we talk a little bit about the guardrails ecosystem, and I'll go through each of these components in turn and how we put them all together. So the LLM, the generation server, I think people are very familiar with the model server serving the generation model. Next, we'll talk about the detectors. So these are the components responsible for identifying risk in the input. And as I mentioned earlier, there's a lot of different challenges in the variation in what detectors do, the different input requirements. Some might take just text, like the user input, or some might take both the user input and the generation model output. And lastly, this is a constantly evolving research field. People are coming out with new detectors every day, whether it's different encoder models or LLMs themselves that are fine-tuned to be able to detect different risks. Next, we have chunkers, and these are components responsible for chunking or breaking down input. And this is including but not limited to just tokenization. And this is helpful in the case where your detectors might take different sorts of inputs. Say your detector was trained on sentences, you'll need something to sort of pre-process that input. So a chunker might be helpful to break that down. And this might also be helpful, say your detector is working or trained on code. And how do you separate out the different functions or parts of the code that you would like to specifically focus on? And lastly, we have the orchestrator that basically calls all these different components. We have an orchestrator example that is open sourced with an Apache 2 license. And basically, as its name says, it manages the request flow, calling all these different components, whether it's your different detectors or your LLM model server that you want to essentially guardrail. And so then it will aggregate all the different responses from all these different servers. And basically, we have some endpoints that will go over that, some of which provide the sort of end-to-end experience orchestrating both the generation calls and the detection calls. So this is what the orchestrator looks like in practice. The user makes a generation call. The request will, or the user input will go to all these different detectors. The chunkers that are applicable to the particular detectors will be called. And then the orchestrator will pass this along if nothing's deemed unsuitable to the generation model of choice. And right now, we expect there to be a router to be able to direct, if in the case there's multiple model servers in the ecosystem, to direct which model server will be the one targeted. So now we'll talk a little bit about the details of the orchestrator, specifically starting with the API, and then dive a little bit into the different APIs that the orchestrator is talking to do all this orchestration. And so the orchestrator API we have today is broken into sort of two large sets of endpoints. One is the generation with detection endpoints, and the other is standalone detection endpoints. So the generation with detection ones essentially means with one call, one user call, you can do both the generation and any detection. So whether it's on the user input or generation output or both. And then there's the set of standalone detection endpoints we have, and this allows users to essentially bring their own input or bring their own generations that they want to run detections on. And this is helpful for users who may want to host their model maybe somewhere proprietary, somewhere they don't want to share, but then still be able to run detections on those outputs. So now we'll talk a little bit about addressing all the challenges I mentioned earlier. And so, as I said, there were a lot of API differences in all the generations and various serving solutions. So essentially, we use very structured APIs in order to talk to all these generation model servers. And so we essentially expect very structured APIs for text generation and chat LLMs. And we support right now multiple generation providers. TGIS was built from an early version of Hugging Face's TGI API, and also VLM, which supports the very popular OpenAI completions, chat completions. And to tackle the challenges of the various detection types, we defined a detectors taxonomy. So right now we have these sorts of detectors: content, chat, generation, and context. Right now, content detectors, some sort of examples, these work on single texts and messages, and these are basic examples, let's say HAP, hate, abuse, profanity detection, or PI detection, so personally identifiable information. You just want to check those for particular things. And then chat detectors work on the whole chat history, so these are a little more structured. Think like chat messages with roles and particular messages. So roles might include like user, assistant, system, that sort of thing. And you might be interested in seeing what develops over a whole chat history. So an example might be something like egregious conversation, where over the course of the chat history, you're trying to see if the assistant is responding more and more egregiously. Generation detectors basically work on prompt and generated text. The example I gave earlier, answer relevance, would be one of those. You're seeing how relevant the generated text is to the original prompt. And lastly, we have context detectors where you're bringing outside context. So this may look like different URLs, different documents, doesn't really matter, but you're looking at how relevant those are to your model output. And so currently, our detectors API that the orchestrator uses to talk to all these different detectors is defined with one endpoint for each part of the detector's taxonomy. So there's one endpoint for each of the contents generation, chat, and context detectors. And right now, it's limited to text. We've been focusing on large language models in particular, but as you can see, it is very flexible and can be expanded to account for other modalities. So now I'll talk a little bit about some of the considerations for building the framework and some of the other challenges that we faced in building the framework itself. So things like the streaming versus unary output, the performance considerations, and the configuration flexibility. So to talk about streaming, it's easiest to go through an example. So let's say we have a user prompt, tell me about corporation Y. And we give that to the input detectors, it says it looks okay. And so that user prompt is passed to the LLM, which is requested to give a streaming output. So streaming output might look like, oh, a few tokens at a time. Let's say it gives like one word at a time, corporation Y, et cetera. And say we still want to run some detections on those model outputs. Let's say we are interested in a competition talk detector and a PII detector. The competition talk detector, just to check, oh, if your model starts to talk about your competition, you might not really want that in a customer-facing application. And a PI detector, since we don't want to give out people's personal information. And let's say the competition talk detector is trained on sentences. We essentially leverage a chunker in order to create from the streamed output the sentences that the detections will be run on. So as you can see here, this sentence chunker can be leveraged to create the sentences for the competition talk detector. And if the PI detector, let's say it has a simpler implementation, it's just regexes, checking for social security numbers, phone numbers, and such. With the simpler implementation, a chunker can be used to leverage just a few words at a time, or in the very trivial scenario, can be used to pass the whole document. Next, performance was a really large consideration for our framework. We had an earlier, less distributed version that was built in Python to do both this orchestration and also running all the different models, whether for detectors or chunkers, but that was way too slow. Python was probably easier to develop and for people to approach, but we really wanted this component to just focus on orchestration. And so we decided to build this orchestrator in Rust and make sure that the models were not running in the orchestrator itself. Anything that required models would, like the chunker detectors, the actual LM server would be talked to by the orchestrator, but not be incorporated into the orchestrator itself. And so this way we were able to do other optimizations, such as make parallel calls to detectors, and we decided to be able to short circuit on unsuitable input. If your detectors or detector configured has already decided your input is unsuitable by any means, why waste GPU resources for your expensive LLM? We might as well just tell the user their input is inappropriate. Lastly, we wanted to make sure there was a lot of configuration flexibility, since the orchestrator talks to potentially many different servers if you want to incorporate many different detectors in your ecosystem. So we basically want to allow people to bring their own servers and make it as easy as possible. So really, you just have to tell us how to talk to your particular servers. So include server information in the configuration, whether it's host name, port, TLS connection information. But then they can kind of be anywhere as long as the orchestrator has access to talk to it, whether it's different namespaces or different clusters. And if in a container format on the cloud, you can optimize where you place your servers to minimize the network latency. And so the orchestrator is part of the Red Hat TrustedAI open source ecosystem, but it is also part of the Red Hat OpenShift product. If people are more interested in a cloud scenario, the users can deploy a Guardrails orchestrator instance through a custom resource definition managed by the TrustedAI operator. And it's sort of the same idea. You just provide the configuration for all your different servers via a config map. And if anyone is interested in this sort of use case, the Red Hat documentation is available on this QR code. And going forward, we have some future work that's not set in stone, but some of our ideas are we want to expand modalities, support text-to-image generation, and of course, that will come along with detections on images. So to summarize some of the key takeaways, we want to emphasize the importance of guardrails, whether it's for different business use cases, like making sure your models or internal business models aren't talking about your competition or detecting hallucinations in general. Next, the importance of guardrails and orchestration for guardrails. Essentially, to add guardrails, you may have to coordinate a lot of different servers, a lot of different components. Users this way, by leveraging the orchestrator here, don't have to orchestrate all of these inputs and take into account all the different factors in adding guardrails themselves. But we also went through a lot of different factors in adding guardrails that might be applicable to other LLM application building scenarios. So things like the inputs and outputs of various guardrail detectors, how to take care of streaming, and the different operational factors in adding guardrails are also important. So things like considering the performance of adding guardrails in general, being able to be flexible to all of the different implementations, and essentially allowing users to bring their own implementations of detectors or generation servers. So as I said, the orchestrator is open sourced with an Apache 2 license, and it's available at this QR code here. Thank you all for your time, and I can take any questions if there's still time.
Very interesting, thank you. Maybe I missed, do you have any specific about prompt injection inside this orchestrator? Prompt injection detection or something like that? You mentioned at the beginning something.
I didn't talk about the specific models or techniques to do so. Things like Granite Guardian has a jailbreak risk detector as part of it. And then within the guardrails framework with the orchestrator, that can be leveraged on the input detection side.
Okay, yeah, maybe we can catch up because we did some experimenting in multi-agent scenario about that.
Yeah.
Good.
Okay, any other questions? All right, let's jump into the next talk. Thanks a lot, Evaline.